Hello, you are welcome to today's lesson. And today I'm going to treat theory of logarithms. And I have about 3 questions that I will solve under that. The first one is simplify log 27 over 32 to base 10 minus log 125 over 9 to base 10 plus 2 log 1 over 45 to base 10. So we start. Solution. Before we start, we have to remember that in this case, we need to use board maths. This will guide us to know what to do. In other words, and we know that in logarithm, subtraction is division, while addition is multiplication. So, start, we have log 27 over 32 minus log 125 over 9 plus 2 log 1 over 45. Going further, as I said earlier, we have to remember board mass, bracket of division, multiplication. So that will give us log, which of big brackets, 27 over 32 divided by 125 all over 9 plus, this one should be 2, please, plus log bracket 1 over 45 raised by 2. So in continuation, we go further. Log 27 over 32 multiplied by, introduce multiplication sign, and then you have to interchange the numbers. That's 9 over 125 plus log bracket 1 over 45 all raised by 2. Now, since we are talking of the same base 10, so we have to bring everything together, and that would be log 27 over 32 times 9 over 125, bringing in this, will now be multiplied by 1 over 45 multiplied by 1 over 45, because it is raised by 2. So, we continue. 9 can divide 9 to give us 1. 9 can divide 45 to give us 5. And 9 here is 3. 9 here is another 5. So, at this point, we'll just simplify. That should be log 3 times the numerator should be 3 all over 32 times 125 times 25. So, in order to continue, we have to multiply through. And then in doing that, you have to, since there's nothing that can divide, we have 125 by 25. This is 5 times 5, 25, 2. 10 plus 2, 12. 5, 6. That's 5 times 1, 5 plus 1. 6. This time this is 10, 0, carry 1. This time this is 4 plus 1, 5. And this time this is 2. So that is 5, 2, 1, 3. That is 3, 1, 2, 5. That is log 3 over 32 times 3, 1, 2, 5. Sorry, 3, 1, 3, 1, 2, 5. Then we multiply further. And if we use our calculator to check, so I use calculator to check, and that will give us 32 by 3125. That's 100,000. So if we use calculator to check, we discover that from here we have log 3 over 100,000. And that is log 3 over 10 raised to power 5. Yes, 10 raised to power 5 is 100,000. But at this point, we can now separate it and have it as log 3 minus log 10 raised to power 5. And that is log 3 minus 5 log 10 to base 10. And again, we know that the log of any number to the same base is 1, which means we are now having our final answer as log 3 minus 5, because log 10 to base 10 is 1, which can rewrite and have it as minus 5 plus log 3 to base 10. You can leave it like this, or you write it in this form. So that is the answer to that. So we are about to go to the question number 2. Okay, to continue, this is question number 2. And we are told to solve the equation 2 raised to power 2x plus 1 minus 9 times 2 raised to power 2 plus 4 equal to 0. So, solution. By looking at the question from laws of indices, we know that this equation, this one, should be multiplied by another 2, because when you're multiplying items of the same base, you add the powers. That is from laws of indices. So this one would be 2 raised to power 2x times 2 minus 9 times 2 raised to power x plus 4 equal to 0. So what I mean is that if you have 2 raised to power 3 times 2 raised to power 2, for instance, it's supposed to be 2 raised to power 3 plus 2. So addition of this one means that we have to multiply this by another 2. And that is what I have explained. So we'll move on. Now, to make the question a little bit simpler for us, we have to represent 2 raised to power x by something. So let 2 raised to power x equal to 8, for instance. And rewriting the whole thing, we have 2 raised to power x all squared, that is for this one, times 2 minus 9 times 2 raised by x plus 4 equal to 0. So this will now lead us to a squared times 2 minus 9a plus 4 equal to 0. And that is 2a squared minus 9a plus 4 equal to 0. So from here we can now factorize to get our answer. And then in this case, we have to think of how to factorize it, or you can use any of the other methods. So for us to factorize, the method is this. Use the coefficient of a squared to multiply this value. That is, this 2 times 4 is 8. You will now look for factors of 8 that will give us plus 8 when we multiply, and when we add or subtract, we get minus 9. And I think what we are supposed to get is minus 8 minus 1. So minus 8 times minus 1 is plus 8. While minus 8 minus 1 is minus 9. So this will break this down to involve those two values. So that will be 2a squared minus 8a minus a plus 4 equal to 0. And then we can now factorize by grouping. And that is, what is common here is 2a bracket a minus 4 minus what is common here is 1. That's a minus 4 equal to 0. And whenever you are carrying out this type of factorization, you check and make sure that whatever you have here is what you must have here. If the value you have here is different from this, it means you have started making a mistake. So move on. That will give us 2a minus 1, that is this and this, into a minus 4. So equal to 0. And that means that 2a minus 1 is either 0 or a minus 4 equal to 0. And in that case, it means that 2a is either 1, that is this one crossing over to the other side, or a is equal to 4. Therefore, a is either 1 over 2 or a equal to 4. So we have two values now, and we have to go back to the substitution. So if a is equal to 2 raised by x, which is equal to half, it then means that this will lead us to 2 raised by x equal to 2 raised by minus 1. But they have the same base. That means that x is equal to minus, therefore, x is equal to minus 1. But if a equal to 2 raised by x, which is equal to 4, this is the same thing as 2 raised by 2. So 2 raised by x equal to 2 raised by 2. Therefore, x is equal to 2. So finally, we have our answers. X is either minus 1 or 2. So that's the final answer to that. And that is how to solve the question. So we are going over to number 3. Okay. Question number 3. We have it on the board. But to find the value of x correct to 3 significant figures, if 0.716 raised by x is equal to 0.415. And you discover that for us to simplify, it may not be so easy. So we have to apply the method of change of base. So, to apply the method, it means that we have to take the log of both sides to base 10. Solution. Take the log and logarithm of both sides to base 10. That means we are now talking of log 0.716 raised by x is equal to log 0.415 to base 10. And again, from laws of indices, from laws of theory of logarithms, this is x log 0.716 equal to log 0.415. And that means that x is now equal to, use this to divide this. It's equal to log 0.415 everything over log 0.716, which is, then you have to go to the anti-log and check. So this is bar 1 point. Yes, bar 1 point. So we'll go to the log table and check. So we're now checking the first one, 41/5 ordinary log. (41/5), and that will be 41/5 is 6180. 6180. Then all over 71/6. 71/6. 71/6 is 8549. 8549. 8549. So, yes, we continue by now using log to simplify further. And in order to do that, I want you to know that when you have a question like this bar 1 shows that this is -1, and this -1 is not affecting this. In other words, this means -1 plus 0.6180 all over -1 plus 0.8549, which means that in each case we have to subtract in order to give us the expected value. So we have -1.000, then plus 0.6180. And that will give us 0. Pick this one to the other side. You have, this is 2. Remaining 9. 9 minus this is 8. Remaining 9. 9 minus this is 3. And then this will be 0. So that is about that. Then handling this in the same way. Handling it in the same way, we have minus 1.0000 plus 0.8549. Again, you have this is 1, and 9 minus 4 is 5. 9 minus 5 is 4. 9 minus 8 is 1. Minus 0 point that. So, bringing them together from what we have here now, then this will give us minus 0.3820 all over minus 0.1451. Negative will cancel, and then we use our log again. That means we have number log. Then 0.3820, 0.1451. This is about 1. This is also about 1. So we go back to ordinary log and check. The first one is 38 under 2. 38 under 2. 38 under 2 is 5821. 5821. Then we now check 14 under 5 difference 1. 14 under 5. 14 under 5 is 1614. Difference 1. That is 1617. That's 14 under 5. Difference 1 is 3. 1617. 1617. Since we are dividing, we have to subtract. 11 minus this is 4. Remaining 1. 11 minus, this is 0 now. 1 minus 1. This should be 2. And this is 4. Bar 1 minus bar 1 is 0. Bar 1 minus bar 1 is the same thing as minus 1 plus, minus 1 minus 1, which is something as minus 1 plus 1, and that is 0. So that is the explanation to that. So we move on, and the next thing we have to do to get our final answer is to check with anti-log. So we're now going to look for anti-log of 42 under 0 difference 4. Anti-log. Go to anti-log table and check 42 under 0. 42 under 0 is 2630. 2630. Difference 4. Difference 4 is 2. Difference 4 is 2. You add the difference. That is 2. 362. So we have 2632. Now the characteristic here is 0, and because of that, you have to count 1 digit before we put our decimal points, and that is 2.632. But we are asked to approximate to 3 significant figures. And that means that our final answer is approximately equal to 2.63 as the final answer. So we have come to the end of the questions because we have only 3 questions. So I would like you to like, share, comment, and subscribe. If you have any question, you can put it in the comment section. Or if you have any topic that is giving you problem, you can also put it there so that in my next video, I can now give attention to it. Thank you till the next lesson.